Welcome to this informative video featuring Byron's song, as he takes us on a journey through one of Optilogic's latest additions to the resource library, the Multi-Year Capacity Planning Database. In this video, you'll discover how this database can empower businesses to make informed decisions about investing in additional production and distribution capacity, particularly when faced with the challenge of accommodating a growing market. Byron will be showcasing a real-world example of a European cheese manufacturer who has sufficient capacity to serve the Western European market today, but needs to expand to cater to the booming Eastern European market in the next 5 years. With the help of this powerful database, you'll gain insights into where and when to invest in additional capacity, ensuring that your business stays ahead of the competition. So let's dive in and explore the power of the Multi-Year Capacity Planning Database.
Let's start by using the analytics dashboard on Cosmic Frog to review the demand profile. The setting of this model is in a European-based cheese supply chain. We can see the demand map here, which shows the demand comes from each country in Europe, and we can use this toggle here to navigate through the different period in this model. We have a 5-year period in this model, and if we look at the current year, we can see the biggest demand comes from the mature market on the east side of Europe. But the business is forecasting in balanced growth in the next 5 years. There's a growing trend in the east of the Europe, and if we look at the year 5 in our demand profile, we see the demand is really shifting to that market. So we can also see this trend in this bar chart, growth by market, and we can see the growing market in the light blue color is growing much faster. The two markets, the growing market and mature market, start almost head on head, 50-50% split between the two. But by year 5, we would see 62% of the growth of the demand is from the growing market. With this shift of demand in our supply chain, our network also needs to adapt. Now let's have a look at the network map. Using Cosmic Frog, you can visualize the supply chain using different layers on the map. To start with, we're now showing the 3 suppliers in our supply chain. These are farms in Germany, France, and the Netherlands. The suppliers will be supplying the 2 plants we have in the network, and they're in Belgium and in Germany. So the first business question we're going to be exploring is whether the current production capacity is going to be sufficient for the growing demand, and if we need to make an investment to expand the production capacity. Next, we can look at the existing distribution centers. We have 3 distribution centers in these locations, and these are historical locations of the DC, and we also want to explore for our distribution network if they are in the right location, and what happens if we add another one, where should it be, if we should consider closing some of the existing DCs. Before this study, we have already identified a list of candidate locations. So you can see them here in Madrid, Paris, here in Berlin, in Prague. So we're going to be asking the model to explore these candidate locations and recommend a number of them to be added to the network. We can also see the customer locations. I made them quite small so they're not going to be too noisy on the map. But as we discussed before, they are representing the country level demand. We can have a look at the current supply flow in the network. So the replenishment flow is linking the plants to the distribution centers. We can see the three distribution centers are being supplied by the 2 plants. And the DCs are in turn servicing different countries, customers from different countries in Europe. So that's the current supply network. Next, we want to introduce the products and the bill of materials as input in this model. To do that, we'll be going to the Data tab, and here we got a list of tables we've already populated for this model. We can have a look at the products. The product table lists is a unique list of all the products we're modeling, and some of them are finished goods. These are different type of cheese as our finished product. We also have the intermediate products. That's the bulk cheese and the raw materials that's used to make the bulk cheese. To link these raw material components and finished good together, we need to use the bill of material table. Let's go there. And you can see the bill of material table defines the relationship between the different products and the quantity of conversion. So this model basically considers a multi-layer, multi-product bill of material, and you feed the model with the finished product demand, and the model will consider the dependent demand automatically. Next, we want to have a look at the current production capacity, which is set up in the work center table. As you can see, we've got 2 plants here, plant 1 and plant 2, and we have existing production lines. So there's one line in plant 1, there's another line in plant 2. We've also set up an overflow site, which is used to capture any overcapacity. And the current production lines are defined with a throughput capacity of 90,000 per year. And you can also see some other information here. The current work center will incur a 20,000 annual fixed operating cost. We have also set up some potential work centers. I call it plant 1 new line and plant 2 new line. And these new lines will have the same capacity as the existing 90,000 per year. They have the same operating cost, but they have a fixed startup cost, meaning if the model decides to activate this production line, it will incur a 50,000 one-off startup cost. And you can see the initial state of these new lines are set to be potential. The work center status is set to be exclude, so they are not being considered in the baseline. Later we're going to use scenario to switch them on so that the model will consider open them, but that will only happen if it's necessary, because it comes with fixed operating cost and fixed startup cost. Now the first business question is the current production capacity sufficient for the future demand? We've already run the baseline scenario. To review the result, we can go back to analytics, and we can look at this dashboard I've created here. So this one shows the production capacity And in the first view here, I make it a little bigger, that shows in the scenario 1A, which is our base constraint scenario, we have plant 1 and plant 2 delivering all the demand in year 1, year 2. But from year 3, we see a new color, which is the overflow site, which means the model is saying the current capacity of the plant 1 and 2 won't be sufficient. If we hover over here, you can see in year 3, both sites are already maxed out at the 90,000 work center capacity we were reviewing earlier. And the remaining volume, 11,293, will have to go to the overflow site. So this is telling us our current capacity in the production plants will not support future demand from year 3 onwards. Now let's go back to the dashboard and review the expanded capacity scenario. This is from scenario 2, consider new lines. In this scenario, we've allowed the model to consider the new lines we've set up earlier with the fixed operating cost and the startup cost. And we can see actually there's no longer overcapacity in this scenario, and we can hover over here in these last 3 years to see the volume of plant 1 stayed as 90,000, but plant 2 has increased over 90,000. That means the model decided to put more throughput via plant 2 because that is the better location given the future demand out of the 2 plants. We can also review the detail over here in this table of the throughput per work center. So in the baseline scenario, we can see there's the overflow site is being utilized, and both production lines, existing production lines, are maxed out at 90,000 from year 3 onwards. Now looking at scenario 2, where we allow the new lines to be considered, we can see this new line in plant 2 is being used from year 3 onwards, whereas both the existing lines are maxed out. The new line in plant 1 is not used because the model determines it's sufficient to only open up one new line in plant 2, so there's no need to open another one. Now let's look at the second business question, which is about the distribution network. Before we do that, let's go back to the input table and review the facility table. In here, we set up the different sites in the model, the overflow site, suppliers, plants. We also set up the DCs, existing DCs, and the candidate DC locations. If we pin the column to the left and scroll to the right hand side, we can see some additional information we've set up here. So for the candidate DCs, we have some startup cost and fixed operating cost set up. So the model will have to consider these costs before opening these sites up. We also define the throughput capacity of the candidate DCs and the existing DCs. And we can see there's a throughput capacity limit for the existing DCs, and the DC3 is a smaller DC. Therefore, for one of the scenarios, we're going to consider closing this DC3. Here again, we've defined a fixed closing cost. If the model wants to close the DC, this cost will be triggered. Another interesting setup here is the fixed operating cost for the existing DCs is set up as a step cost. And we can go to the step cost table to review that. So we know the throughput capacity of DC1 is 100,000, and this step cost incentivizes the model to keep a better balance between the DCs. So this is saying between the flow from 0 to 80,000, there's a fixed operating cost of 160,000. Beyond 80,000, up to 100,000, which is the maximum throughput capacity, a cost of 200,000 will be applied. So this incentivizes the model to balance all the sites to be 80% loaded, because it can avoid the additional shift cost. This is a very useful feature to model different shifts as well. Now, having set these things up, we can set up our scenarios. If we go to the scenario setting, we can see how the baseline and the scenario 2 was set up that consider new lines. We also have two scenarios here set up, which says if we keep the current 3 DC but add a new DC, where should it be and when it should be. And the next scenario is to say if we also consider closing DC3 but keeping the maximum number of DCs to be 4, which 4 it should be. To review the result, let's go back to the analytics and have a look at the optimized distribution dashboard. So from the scenario 1, we know there are 3 DCs, and scenario 2 as well, because those two scenarios was about the production capacity. But we can use scenario 2 to compare with scenario 4A and 4B. Scenario 4A says if we want to consider one more DC on top of the DC 1, 2, 3, it would be the candidate DC in Romania, Bucharest. And we can see from year 3, the model suggests opening this Bucharest DC, and that is partially driven by the growing demand in the east of Europe. In scenario 4B, the model actually decides to close DC3 and open same Romania DC in Bucharest, but also another candidate location in Copenhagen. Let's have a look at these results on the map. We can switch the baseline map to scenario 4A, and this is showing if we were to add a new DC, it would be this Romania DC in Bucharest, and this DC will be serving the growing demand from Eastern Europe, in Ukraine, Turkey, and Greece. For scenario 4B, we can see the DC3 is no longer linked. So this is the DC we're going to close. Instead, we're going to be serving the customers out of this Copenhagen DC. Now, to summarize, we can have a look at the scenario comparison dashboard. This shows the total supply chain cost in all of the scenarios. In the baseline, we see there's actually a low cost, but that's because we are not serving all of the demand. To be able to serve all the demand, we had to expand new production lines, and the model chose to do that in the plan 2. And we can see when we hover over this bar, there is a fixed startup cost for setting up new production lines. Looking at scenario 4A, we can see there is an additional fixed startup cost because we had to set up a new Romania DC. But on the bright side, we will see some significant saving from the transportation cost, because our new DC will be closer to the growing demand in Eastern Europe. The next scenario gives the model even more freedom to optimize by allowing the model to consider closing DC3 and open up potentially 2 new candidate DCs. And we can see that the cost is reflecting the capex investment in the closing cost, the startup cost, and the fixed operating cost. But the benefit is even lower transportation cost and improved service levels. That's it for this demo. Thank you very much for